box setup. It is a wood box built for this. It has circular holes that are covered in foil, and there's one on each face, and then you can put a light bulb in the top. Don't need anything quite this fancy. You can certainly use cardboard. That's where we started. And then once we decided we really liked them, we had these made. If you use cardboard, just watch the bulbs because they get hot. So you don't want to leave them unattended by any means. So I'm just going to poke a hole in the face. Move this so I can see. Got another one. And another one. So what are you seeing? What shapes are these? If you had to describe them, what would you call them? And keep in mind, I am making a pinhole with a pin. Big pin, but a pin. So are those little spots of light? If I take the light inside, well, you can see I'm moving it, but let's see if I can turn it, like rotate it around. Look at that. That's kind of cool. So I've got that shape and then that shape. All right. Now, let me try. I'm going to rotate the whole box. You can see what I'm doing here. I'm going to just twist the box so a different face is facing our screen, and our screen is just a white wall, nothing fancy. And now we have this one. So a little bit different shape. If I thought of this as an arrow, what way would you say it's pointing? Keep that in mind as we take the light bulb out and look at it. I'm going to open the box, take out the light. You definitely want to let the light cool off. They tend to get pretty hot, depending on the wattage, very hot. So this is the light. Is that what you expected? Keep in mind it was hanging like this inside the box. If I rotate it like this, what does that look like to you? Look familiar? What if I turn it like that? Like that. I wanted to show you this drawing just for a second and see kind of what's going on. So this would be the light bulb. We've got a little arrow here, so we have an up and a down inside the box. And all the rays reflecting, or in this case actually emitting from the light bulb from everywhere, but we're just going to concentrate on the tip of the arrow and the bottom of the arrow. They go in every direction, but if we cut a pinhole, only one can come through. So this is the one that's lined up and it gets through. This one's lined up and it gets through. That's the top of the arrow, which is here, the top of the arrow. This is the bottom of the arrow, which is here. And so you can see how it gets upside down, and because it's just such a tiny little bit of amount of light, it gives you a full image on the screen. If we didn't have a pinhole, there's no pinhole here, all those light rays end up on the screen. So there's this arrow picture, there's this arrow image, there's this arrow image. Be everywhere. This whole screen is covered in images of this arrow. If you could come back and put a pinholes like one here, one here, one here, you would get these three distinct images like we did when we did our experiment where we're punching different holes, multiple holes, we're getting multiple images. We're going to look at another light bulb I have all set up here. And I've turned it around so there's no pinholes on this far screen over here. So I'm just going to make a few. There's one, there's two, there's three. So again, pay attention to what you can see. The shape, are they all the same? So here is the bulb pulled out of there. Can you see that filament? Looks just like the picture in the pinhole image of it. So it's like a C, kind of a... And then all the other little pieces you would have seen would be either reflections inside the bulb or maybe those arms that are holding the filament. They can show up too. So I have the lights turned pretty far down. They look black on the camera. It's not pitch black in here. But I wanted you to be able to see what I can see on this screen here. So look here with my finger. Do you see this outline? You see this here, right? I'll do it with the cursor, see if that's any more helpful. So see the this here versus this here. Think about what that could be. I'm going to turn the box around just a little bit so you can see. So that's that side. That's that side. So the pinholes are in a different place on this side. So we can still see these shapes here, plus the filaments, what we're used to seeing, but we're also seeing something else. Okay, I've got the lights turned on, so we can open up the box. I just tape it shut because the light leaks out. It's fine when it bugs the camera more than it'll bother you. Here we go, look. Is that what you were expecting? I'm gonna guess some of you yes, some of you maybe not, I'm not sure. If you look in here with your eye, you can see the filament inside the bulb. This is called a diffusing bulb, which means that the coating inside acts like little light sources, which means it's not a single light source, so you don't get these sharp shadows in a room, and that's why typically you don't see the filament as noticeably. So the cool thing about that is it proves to you, or it shows you, it gives evidence that the pinhole isn't really just showing a picture of the filament, it's showing a picture of everything inside the box. Just a question of if it's bright enough or not. If the inside of the box was a little bit brighter, you could see the inside of the box. You could see how it's made. You could probably see these little support features here. So there's nothing magical about the pinhole. Everything inside that's reflecting light will get out. It's just how much light it's reflecting and if it's bright enough to see it. Take a look at the pinhole viewer. Here it is, all made up. I'll take it apart so you can see the pieces. On this end, a piece of foil with a pinhole. You can play around with, investigate different sizes of pinholes and see what that does to the image. And the point of the tube is that it's dark, so that when you look in here, it's dark inside, and then at the other end you'll see the image, and that'll be relatively as bright as possible. So it doesn't have to be a tube, it can be a box or a can. So the features are some kind of darkness that you put your eye inside. And then inside is the foil with the hole. And then in this end, this is the screen. And I would play around with different things. This is just a grocery bag. You could try wax paper or glassine paper. Just try different things and see what works best for you. You do need to have a nice bright sunny day for this to work well, and even with that, you'll see, as you'll see the image in a minute, it's a pretty dim view. So
I always laugh or am a little bit sad when people complain about their cameras not doing a good job in low light. And I think, no, what you should be saying is your eye is amazing at seeing in low light. In fact, if you do some research, you'll see the way your retina takes in the light. It's actually not a simple scale. It's a logarithmic or an exponential scale in terms of the brightness. So you have no clue when you're looking at something that seems dim, it could be 1,000 times dimmer than something that's a little bit brighter. And so with a camera, it can't compensate nearly enough for that. So that's what's going on. And so with this, you'll see a nice bright, on a bright day, you'll see, and you should see a pretty decent image. So check whether the image is smaller or larger, upside down or right side up, and in color or not in color. So those are things to keep in mind as you're looking through your viewer.
We're looking through our pinhole viewer. Got some snow on the roof, some blue sky, some trees, a fence, some snow with shadows, more trees. The brighter the day and the more contrast, the easier it is to see and make sense of what you're seeing in a pinhole viewer. Looking outside on a beautiful sunny day with snow on the ground, which is why it's super bright, even though it's winter. Can you tell if it's right side up or upside down? This viewer, you should never look directly into the sun with this or any other viewer. I hope that's obvious, but I just will say it just in case it's not.
All right, we have our foil frame here with some crazy shapes cut out of it. Kind of a star shape, kind of a teardrop, and then you can see the shadow it's making on the wall. So see the shadow? Pretty much the same, pretty much what you'd expect. But as I pull it away, watch what happens and see if you could say what shapes they're becoming and if they're the same or different. So what do you think? What shapes would you call those? Were they the same? Were they different? I know they weren't clear, and there's a reason for that, but what shape were they? That's what you want to pay attention to.